Hello. Hello. It's working right now. Okay, great. Thank you very much for a warm introduction of me. And welcome everyone to this room. I'm very excited to be here to have a talk about something that I like, particularly in the development around OSS sphere. So my talk title is, as titled here, a reliable development release workflow for OSS Python library. First of all, my name is Yuichiro Tachibana, coming from Japan. As introduced by her, I am a software developer who loves OSS activities. Well, the list is so long, and you don't have to see all the detail, but here I want to say I love OSS. I have been contributed to several OSS projects where I wrote some Python code and I learned something from that process. If you're interested in these activities or these talk materials, you can find me online as a username WHITPHX, and you can access GitHub or my website where you can find the slide material as well. I also posted the slide material on Discord before, so you can find it online already. So, right, let's start the talk from now on. This is the project that I'll use as a case study here in this talk. It's a Python library called Streamlit WebRTC. You don't mind the details of this library, actually, but we use this as just a use case here. It's a Python library published on PyPI and have been developed of me and with huge support by external contributors, and it have some already more than 100 releases on PyPI. And so I am going to show the workflow that we have developed during this for the development of this library, and how this workflow evolved over the years of the development of the library. By the way, if you are interested in this library itself, I gave a talk about it in EuroPython 2022, so please check the recorded video of that. OK, so how do you actually release a Python package first? The simplest way is obviously to run the Python build command and upload it with something like twine upload command from your laptop locally, but it's obviously not the best way because it's kind of a fragile and unstable way. So most mature project will move to CI/CD based release pipeline. Sorry, the display connection is not stable here. But so for this talk, we will focus on this kind of CI/CD based release workflow as a foundation of this kind of discussion in this case. And particularly, my use case, Streamlit WebRTC, is using GitHub Actions, first of all. So these are the two most common starting points probably you can easily find, you can easily start with. One is a GitHub template, and one is our PyPA packaging guidance document that you can find online as well. These are really nice starting point, actually. They include some build and publish CI step definitions. And PyPA guidance also includes some security considerations as well. But neither of them include some kind of testing or more advanced topics like changelog management or version bumping or security considerations or something like that. So we need to cover these kind of just a bit advanced things in this talk on top of these very good basic foundations. So here's what we are going for. Safety, automation, and developer experience. So to be honest, this talk consists of several different items of my personal experiences, knowledges, know-hows, or learning result. So, but I believe these kind of items can be generalized in practice in your project as well, and I hope some of them inspire you. So please pick up some of them if you believe they can be also applicable to your use case as well. So here are more detailed agenda. We will work through 4 areas. First is our test and building, particularly in the idempotent build concept. And then we will go to the next bigger chunk, automating changelog and version bumping together. Next, we are going to take a look about security stuff specific to GitHub Actions as well. And finally, we will take a short look at developer experience improvement. That includes some, deploying a preview wheel packages to the online or something like that. Again, these are just tips I picked up. And so over time, I would like you to pick some of them for your own use cases. All right, let's start with the foundation, building and releasing, particularly releasing. Let me introduce a very important principle that is idempotent builds, right? Where it is very really encouraged that you should build the wheel package that will be shipped only once per workflow, and upload it as an artifact, then download and use it for every places on downstream during the CI/CD pipeline. For example, like when it's time to publish. Never rebuild at publish time. Probably this is interesting to someone who started the CI/CD pipeline constructing based on the older version of GitHub template, the GitHub Action template, because they used the separate build and publish GitHub Actions template, where the publish job run its own build just before publishment. But recently, they updated their template to reuse the once build package in the later steps, including in the publish step. So I believe this is now encouraged by the official GitHub Actions team as well. No, sorry, I said some animation here. Yes, this slide here, this slide shows you should build first in the first job, I mean. Then you should download the uploaded build artifact just before you release the build view here. OK, so we've got builds. But what actually kicks off the release? A release common pattern is tag-triggered releases, right? This is also a very common pattern. For example, like you push a version tag, managed on the Git repository. Then CI does the triggers, the release pipeline. This is really simple and clean, and I am using my use case project is also using this principle. But it raises the question: who creates the tag, and who decides if it's a patch or minor or major version bump? So that's exactly what we will tackle next. It's about changelog and versioning topic. Okay, now this is, to be honest, the biggest part in this talk as well, actually. Changelog and versioning. These two are deeply connected topics because they are really similar thing. And the trick that we like to introduce here can automate them together. I like to think about this as 3 coupled problem. How do you maintain the changelog? Changelog is kind of a release note shipped along with your release package. And how do you decide the next version and create a tag? I mean, determining the version bump level, patch, minor, or major. And how does the build wheel actually know its version? They are not independent because what change determines the version, and the version has to flow through to the package. Let me walk you through how Stream WebRTC package evolved through 4 phases. Phase 1, This is the very beginning phase of this project. Everything was operated by hand. Everything was manual, where I edited the changelog by hand, edit the version string by hand. I determined the next version string by my own brain, and also updated the PyProject terminal version field by hand. It worked, and I think this is a very starting point that most of you will start with. But it's super error prone. You forget the changelog update, type the version or tag, forget to attach a tag before committing, or et cetera, et cetera. Oh, sorry. Yes, there is a very error prone, right? So the project evolved to phase 2. So I introduced a tool to help version bumping. I choose, in my case, bump my version tool. You can choose the tool you like in your case as well, of course. But this tool now helps updating the version string in PyProject.toml, and it also automatically the git tag automatically does the git tag task. But still, it is less error prone, right? But the humans still decide to patch minor major version bumping problem, and the changelog is still edited by hand. The next phase in phase 3, I introduced a hatch VCS package. Now the version string is now not hard-coded anywhere, because hatch VCS just reads the latest git tag at the build time and sets the version string in the package wheel automatically. So bump my version's job is now just to create a git tag in a formatted manner, and hatch VCS does all the rest. So and also hatch VCS introduced a nice bonus for non-tagged build, for example, like a development build that we can get during the development phases on the CI pull request thread. Hatch VCS generates dev versions like 0. something dot dev. In this case, dev 19 plus some commit tag. This is kind of development version that distinguish this very specific build from other git commit build. That's really handy for preview wheels, which we will see later, by the way. But 2 of our 3 problems are still manual: changelog management and version bumping level. So we improved it better and better. So I explored some tools to automate these kind of things. There are 2 main approaches out there. They actually share the same idea. You aggregate structured input to generate changelog and calculate the next version based on that. The difference is the just input source. There are two major ways to do something like this. One is conventional commit-based one, and the other is change set, something like called change set. In conventional commit way, you are forced to git commit in a very formatted commit message with some fixed prefix like feat, fix, or breaking chain, or something like that. Then tools like semantic release or something like that will aggregate all the stacked git commit messages to generate the new set of change log documents and calculate the next version based on these prefixes. And in the approach called change log fragments, the input source is going to be kind of a dedicated files committed to the repository directly alongside the main code base as well. And the principle is very same. Tools like change set, that is widely used in the JavaScript ecosystem, by the way, aggregates the committed files that has what these are changes are representing, and then aggregate the change information, then generate the change log document and calculate the next version. So let me compare them side by side in short. A conventional commit ties version intent to commit messages. You need to discipline on every commit. As I said, you have to follow the fixed format of the commit messages. And if you squash merge, I love squash merge when merging pull request with the main branch, by the way, you lose that granularity. That means that so pull request titles have to follow the same conventional commits rule instead. And honestly, the change log tends to read like a Git log, actually. And the fragments approach, on the other hand, are just files in your pull request. So they survive squash and rebase, and you can edit them even after merge, even after the commit are uploaded to the remote Git repository. I mean, commit pushed to the remote Git repository. That I think is really flexible, and you can oh, sorry. And the changelog ends up being actual human-written prose. So I personally prefer fragment, Git change set fragments approach. But honestly, both work. So you can choose the one you like. Oh, sorry. Sorry, I sometimes forget to move forward these animations. So yes, I like to dig deeper into the things around change sets. In the JavaScript ecosystem, change set is a well-known tool for this kind of thing, actually. It gives you both a local CLI for creating fragments. Fragments here means just a text file that is shown in the previous slide, for example, and calculating versions as well. And this ecosystem or this framework something is now providing the CI, GitHub actions that automates the whole release flow with pull requests. One ecosystem covers everything: fragment generation, versioning calculation, change log generation, and CI automates all of them. So the question is, can we get something like that for Python ecosystem, or the package written in Python, just like my use case? In Python, we have packages like Scribe or Town Crier for changelog fragments. Changelog generation aggregated from the fragment files. You can choose an appropriate tool for your project, of course. In my case, I selected the Scribe, S-C-R-I-V. You configure your categories in project.toml like this. Allowed your predefined categories in project.toml, added, changed, deprecators, things like that. These represent the change type, the type of change you made in your development pull request. Then you will you will create the change set fragment file that, in the case of Scribe, that's going to be just a plain Markdown file. Scribe create command and create it. Then you will write the text, any text you like to represent your change in this Markdown file. Then you can simply add and push this fragment file just alongside the main code base to your repository to create a feature pull request. But there are still some gaps we have to fill in the case of Scribe or even Town Crier or things like that. So a change set covers everything. Change set is a JavaScript framework that covers everything. But Scribe only does change log generations. But in my case, I wanted to do more things. So I wrote two new things by myself. One is a Python script that reads fragment categories to figure out the version bump level to determine a patch, minor, major version bumping level based on this kind of change type. stacked on the fragment directory, fragment files. And also, I also created a GitHub Actions workflow that replicates the change set GitHub Action release flow. Let me show you both. So here's the first one, the version calculation script. You don't have to take a closer look into this detail, but I would like to explain in briefly. So here's a version calculation script. It's pretty simple. It uses a Scribes API to get the first is the version, how to say, the mapping of change type to bump level. If the fragment have an added change type, it's gonna be considered as our minor version bump. Changed type is mapped to minor version bump, for example, but the removed something can be considered as a breaking change. So removed change type is going to be mapped to major version bump because it means it represents something like breaking change, something like that. And in the next part, this script uses the Scribe API to get the collection of the fragment file to scan. Then this script calculates the max level of the version bump level to determine the next version string. This is only like about 50 lines of Python code, but it works really nicely for my use case. And the next script that I wrote was CI pipeline, CI action, reusable action. Here's the CI workflow that uses the Scribe-based approach that I have been explaining in the previous slide. It's all about 150 lines in the YAML file. So we don't have to take a close look into the detail, by the way. I will walk through in a very short manner. This CI workflow is triggered on every push on the main branch and checks for the fragments, committed the fragment files. And if one or more fragment file exists, it collects them, calculates the version, and open or update a release pull request by using the scripts that I have written in the previous slide. And that means the release pull request was just it is reviewing purpose for the maintainers, aka person like me. And when the new commit is pushed to the main branch, and if there is no fragment files, that means the release pull request was just merged, and the push to commit is the merge pull request of the release merge commit of the release pull request. Then this pipeline reads the bump level from the previous commit and creates a git tag and push it to the main repository. Sorry, this is very complicated, by the way, but what it does is very simple, like what I have explained. And this git tag push triggers the build and publish CI workflow, just like what I have explained in the first section of this talk. So it just all depends on whether the fragment files are committed to the repository or not. So here is how it all fits together. Scribe handles the changelog fragments. The custom script I wrote and CI workflow handles version bumping and tagging. Then HVCS reads the tag at the build time to set the package version string embedded in the build wheel file. And Scribe and HVCS are both off-the-shelf tools, and custom stuff just connect them. And remember that dev version bonus from earlier, HVCS gives every non-tagged build on unique dev version. So that is perfect for those review wheels. This is the demonstration of the actual workflow. As I said, if you commit the fragment file to the future pull request, and the future pull request is merged to the main branch, the automated bot will create a pull request release pull request with the automation. And if the maintainer approve it and merge it, the bot create a Git tag automatically, then the publish workflow is going to be triggered automatically. And this merging and approving is the only manual thing that now maintainers have to do by hand. Right, so we are moved to the security session. When you accept contributions from external developers, some security considerations should be needed in your CI/CD pipeline. This is a very typical case in the OSS project. So in GitHub Actions, different events run in totally different contexts. For example, the pull request event that triggers the CI workflow runs the pull request author's code in the authored context, which means that external contributors can arbitrarily code in your CI. But GitHub does protect you. It gives only the read-only token, no access to secrets. So there is no capability for the CI run in this context to access any secret. On the other hand, workflow run event that is triggered by the completion of other workflow runs in the default branch context, where only merge code runs, so it gets full access to secrets. So the principle is very simple. Test on pull request event and others, including deployment or things like that, should be done in the pull workflow run context. So here's how we split into 3 files. Test build YAML file that triggers the push, that is triggered by push or pull request. That runs test, builds the field, but no secret access. So I added the post build YAML that is triggered when this test build workflow finishes and run in the default branch context with secrets, so it can publish the package to PyPI and create releases. And changelog.yaml is the file that we have explained in the previous section. And last security piece, how do users actually trust your package? Let me walk through it very briefly because this is a topic that already explained in the PyPA document, by the way. The key message from this slide is please follow that document. PyPA is a document. PyPA or PyPI is now offering the official way to protect, sign your package on the GitHub Actions or any other CI/CD pipeline. So this is highly encouraged to use this kind of security techniques when you build a release pipeline in your CI/CD. Final section. That is developer experience thing. If you make it easy to contribute correctly for external developers, people get an easy way to do contributions to your repository. Very easy. But in my case, this is very simple. We announced for external contributors to create the fragment file just by copying and pasting the scribe command from our README when you create any contributions to our repository. And when they create a feature pull request, the automated bot automatically will build a preview Python wheel and post to the reviewable link to the pull request thread so that the external contributor too can easily review their contribution result. Sorry, we are getting running out of time. I'm getting the kind of rush. So, right, we're gonna skip the very detail of this preview. Here are some key takeaways. Single source of truth for versions and change sets is a very nice principle, at least for my case. And automate the boring stuff, but keep humans in the loop for the important decisions like determining release decision and think about security from the start and make it easy for people, for external contributors to do any contributions. And do not be afraid to steal ideas from other ecosystems, where in my case, I stole the idea from JavaScript ecosystem, actually. It actually worked nicely. And the whole approach was inspired by change set, in my case, from JavaScript. Right. This is the last slide. Here's all the links if you want to get deeper. And as I said, I posted to the Discord channel already, so please find it online if you are interested in this talk. I hope you get some inspiration from it. Thank you very much for listening to this talk.